Hey everyone, welcome back to the Bare Metal Embedded Systems Programming from Scratch series. In the previous episode, we wrote pure assembly code to blink the onboard LED of the Arduino Mega by accessing the hardware registers directly. And now, it's time to bring that code to life. In this video, we're going to assemble the code, link it, convert it to a hex file, upload it to the Arduino Mega or the atmega2560 microcontroller, and finally create a Makefile to automate the whole process. So let's dive straight into the workflow that every embedded developer uses when working with assembly. Let's bring the Arduino Mega board to life. This command runs the AVR assembler. It takes your assembly source file and converts it into an object file. An object file is basically the machine code translation of our assembly source, but it's still not a complete program. It also contains symbol information which the linker needs to finish the build. Symbols are just the names in our program. Labels like reset and loop, subroutines like delay_1s and delay_250ms, inner loop labels like ms_inner, and even constants such as DDRB and LED. All these symbols help the linker know exactly where everything should go in memory. So you can think of the object file as a half-built program. The assembler turns our .asm into a .o file, and then the linker completes the job by assigning final memory addresses. In this command, AVR-AS is the AVR assembler, and -mmcu equals atmega2560 tells it which microcontroller we're targeting. -o_blink.o specifies the output file, and blink.asm is the source code we're assembling. Alright, let's copy this command, paste it into the console, hit enter, and there we go, our object file is now created. This command runs the AVR linker. Its job is to take our object file and turn it into a complete executable, but still not the hex file we can upload. The linker assigns final memory addresses. That means it decides exactly where each symbol, every function, every label will live in flash memory. The important part here is the -t text equals 0x0000 flag. This tells the linker, place the start of the program at the address 0x0000 where the AVR reset vector jumps after reset. The -m AVR6 option tells the linker we're using a large flash AVR device, which the atmega2560 belongs to. And finally, -oblink.elf is our output file, and blink.o is the object file we created in the previous step. Okay, let's copy this command, paste it into the console, hit enter. As you can see, our ELF file has now been generated. This one converts our ELF executable into an Intel HEX file, the format required by the bootloader. The microcontroller cannot use ELF files directly. They contain debugging information, symbol tables, relocation data, things the chip doesn't need. The bootloader expects a clean hex file, and that's exactly what AVR-obj copy creates. The flag -oi hex simply means output format equals Intel HEX. So blink.elf is our input, and blink.hex is the final firmware file that we can upload to the Arduino Mega. Now copy this command, paste it into your console, hit enter, and there we go, our hex file is ready to flash. This command uses avrdude to upload the final hex file to the Arduino Mega, to the microcontroller. The -d flag tells avrdude not to erase the chip before writing, because the Arduino bootloader already handles the erase automatically. The -p atmega2560 tells avrdude the exact chip we're programming. -c wiring selects the Arduino Mega bootloader protocol. And -p, capital P, COM4, is the serial port your board is connected to. -B150200 says the upload speed. This is the baud rate. And the most important part is this. This tells avrdude to write the hex file into the flash memory of the microcontroller. Copy this command, paste it into the console, hit enter, and just like that, your assembly program is now running on the Arduino Mega. Now, let's create a Makefile to automate the whole process. Instead of typing each command manually, the Makefile will build everything for us. Assemble, link, convert to hex, and even upload the code to the Arduino Mega. Create a new file in your project folder called Makefile, no file extension. Alright, first I'm going to write the basic project settings at the top of the Makefile. These are just variables to make our Makefile easier to maintain. MCU is the microcontroller we're building for. Port, the COM port used for uploading. Baud is upload speed, and SRC is our assembly file. And the last one, target, is the base name for all the output files. This way, if anything changes, we only update it here. Now I'm going to add the tools we'll be using: the assembler, the linker, obj-copy, and avrdude. Next, I'll write the flags, the options we pass to each tool. AS flags tells the assembler which MCU we're targeting. LD flags says the architecture and the program start address. OBJ flags tells obj-copy to output Intel HEX format. Nothing special here, just configuration. Now, let's define the default target. This is what runs when we just type make. This means build the hex file. Okay, now I'll write the 3 build steps: assemble, link, and convert. This rule turns our .asm file into a .o object file. $less means input and $at means output. This takes the object file and produces the .elf executable. This one converts the ELF file into a hex file, the format we can upload to the Arduino Mega. Now, let's add a rule for uploading the hex file to the Arduino Mega board. With this, we can upload the firmware by running make upload. And that's it, fully automated. Finally, I'll add a clean rule to delete all the build files. These just tell make that these names all, clean, and upload are commands, not files. And that's our Makefile. Now we can build and upload the entire project automatically with a single command, much faster and much cleaner than typing every command manually. Now let's go ahead and test the Makefile to make sure everything is working correctly. Alright, in the terminal, just type make and press enter. This will build the hex file for us. And by typing make upload, you trigger the upload rule, which sends the hex file directly to the microcontroller. The make clean command deletes the object file, the ELF file, and the hex file, giving you a clean workspace. And that's it for this video. We have successfully assembled, linked, converted, uploaded, and automated everything with a Makefile. In the next video, we're going to get started with programming the ATSAM3X8E ARM Cortex-M3, which is the microcontroller on the Arduino Do R3. Just like we did with the Arduino Mega, we'll begin by blinking the onboard LED using C with direct register access, and then we'll do the exact same thing in pure assembly. You can find all the files for this episode on my GitHub, including the full source code and the Makefiles for Windows, Linux, and macOS. If you are enjoying the series, don't forget to like, subscribe, and stay tuned. We have got a lot more embedded programming coming up.